Occasionally we'll be given trigonometry questions to do in 3 dimensions. In this question, in A, we want to calculate qx. To do this, I'm going to imagine that I'm looking at the cuboid from above, so that I would see, if I then join up q and x, I would see a right angle triangle, because this is a cuboid, so that means this angle here is 90 degrees. I could look at this from above and I would see this right angle triangle here. Let me draw that a little bit better. If I can. I would see this right angle triangle, QRX. We know that XR, or RX, is 3 centimeters. We know QR is 7 centimeters. And we know this is a right angle triangle, so if I want to find qx, I can use Pythagoras' theorem as follows. I can say qx squared is equal to rx squared plus qr squared, and I can substitute my numbers in. 3 squared plus 7 squared, which is just going to be 9 plus 49, which is 58. So I can say qx squared is 58. And then to find qx, I can just use, I can square root both sides. So I can do the square root of 58, which is 7.62 centimeters. And then we want to use our answer to part A to work out px using Pythagoras' theorem. So we know now that qx is root 58, approximately 7.62, but if we now want to work out px, I can imagine looking at the cuboid from the side here, so that I can see the right angle triangle PQX, so P to Q to X, and we can write in what we know. So this is P, Q, and X. Right, we know that QX is root 58, so we have root 58. We know that PQ is 5 centimeters, and we want to find PX. So we can use again Pythagoras' theorem, because we have a right angle triangle. We want to find the longest side. PX squared equals PQ squared plus QX squared. So PQ squared is 5 squared, and QX squared is going to be root 58 squared, which is just 58. So to work out px squared, it's going to be 25 plus 58, which is 83. So to find px, I need to square root both sides, so I do square root 83. So px, the 2 decimal places, is going to be, it's about 9, 1 second, here we go, root 83, 9.11 centimeters. Finally, we want to show that angle XPQ is equal to 56.7 degrees to 1 decimal place. Angle XPQ is this angle here, because it's the angle with P as the center. So I can label this triangle XPQ. We have the, well, this is the hypotenuse, PX. Opposite is root 58, and the adjacent is 5. We know the adjacent and we know the opposite, so I need to use tan. So I can say tan of the angle XPQ is equal to opposite over adjacent, which is root 58 over 5. And then to get XPQ on its own, we can take inverse tan of both sides. So I would write down XPQ is inverse tan root 58 over 5. And we can work that out using a calculator, making sure that we're in degree mode, not radians. So let's do that. So I've got shift tan root 58 over 5, and that gives me 56.71. So to 1 decimal place, 56.7 degrees, which is what we wanted to show. Here's a question for you to try. Please pause the video now and have a go, and when you're ready for the answers, press play.
To
calculate the distance px, I'm going to look at the cuboid from below using the right angle triangle XRQ. So I've just drawn the right angle triangle, and I can see that to work out QX, I can use RX, which is 5 meters, and QR, which is 12.5 meters, and then Pythagoras' theorem gives me QX as 13.46 meters. I can then draw the right angle triangle PQX, and I can work out PX, which is the hypotenuse, again using Pythagoras' theorem, giving me 15.66 meters for PX. To work out the angle XPQ, I can simply use, again, the right angle triangle PQX with the opposite as 13.46 and the adjacent as 8. I can then invert, so inverse tan, and I get 59.3 degrees to 1 decimal place. Occasionally, you'll have to do some more advanced trigonometry in 3D. If we look at this question here, in this example here, a rectangular base pyramid is shown where x is the apex or highest point of the pyramid. We're told that angle AXC is 120 degrees. So that's the angle which goes from A to X to C. So if you imagine a triangle AXC, this angle here will be 120 degrees. We want to calculate the length AC and the length BC. To start with, let's imagine that we have the triangle AXC. Now, if I want to work out AC, I know first of all the angle AXC is 120 degrees. We have two sides in the included angle, so we're going to want to use the cosine rule. So to find AC, we substitute into our cosine rule, and we should end up with AC being 173.21 centimeters. Then, to find BC, what we could do is use what we've worked out. We worked out AC. We know that the base of this pyramid is a rectangle. So we have a right angle triangle ABC. We know that AB is 80 centimeters. We do not know BC, but we do know that the hypotenuse of this right angle triangle ABC is about 173.21 from part A. We can then use Pythagoras' theorem to find the shorter side BC as 153.62 centimeters. Here's a question for you to try. So it's a very similar question, but we're told this time it's a square base pyramid. The base vertices, or the vertices of the square on the base, are A, B, C, and D. The apex of the pyramid is Y, and the center of the base is X. AB is 20 centimeters, so you could label that on, and AY is 50 centimeters. Try and work out each of the measurements shown. If you want to resume the video to have some hints, by all means do that. Okay, so if you've paused the video and tried it, here's a hint for AX. So we want to find the distance between A and X. Well, we know that AY, so we know this is 50 centimeters here, from A to Y. We could consider also the distance XY. So we want to find AX. We have a right angle triangle here. Do we have enough information? Yes, we do, because AB is 20. So we know this is 20. And we also know that the base is a square. So we also know BC is 20. So we could consider the triangle ABC. And consider, if you worked out AC, how would that help you get AX, given that X is the center of the square on the base? Okay, another hint for AX. If I draw the square that makes up the base, we have A, B, C, x is in the middle, right? It's right in the center of that square. So if we know that AB is 20 and we know that BC is 20, if I worked out AC, to get AX, I just need to cut that in half. So first of all, AC squared is going to be 20 squared plus 20 squared, which is going to be 400 plus 400, which is 800. So to get AC, I would need to do the square root of 800, which is going to be 10 root 8, so 800. I'll leave it in surd form. That's going to be 20 root 2. So think about then how you could get AX. To get AX, we just need to halve this. So we end up with 10 root 2 for AX, which is about 1.4, approximately. Or actually not 1.4, sorry, about 14.14. So we get x as 14.14 centimeters to 2 decimal places. Think about now how you can work out AY. A hint for AY, given that we know that AX is 14.14, or if you want to leave it in surd form you can, and we know that, well actually we might have been given, have we been given AY? We've been given AY straight away. That's 50 centimeters actually, so there's nothing to do there. If we want angle AYC, however, so angle AYC, different ways of doing this. We've worked out, so one way that you could do it, we know that AY is 50 centimeters, and we know that's going to be the same as YC because Y is directly above the center of the square X, because Y is the apex. So we know that if we could draw a triangle like this, AYC. So AYC. We know this is 50, we know this is 50, and we know AC is 20 root 2. So I'm going to leave it in surd form. So now we have a triangle, all three sides, and we want angle AYC, so we could use the cosine rule. So using the cosine rule, I would have cos of angle AYC equals 50 squared plus 50 squared, take away 20 root 2 all squared, over 2 times 50 times 50. And putting that into our calculator will give, so let's do this. We get 21/25, 0.84. So to get the angle AYC, I need to take inverse cosine of both sides. Let's do that. So I do shift, cos, and I get an answer of 32.86 degrees.